Welcome to our fifth lesson. Today we're going to go over string methods. And so for our first problem, we're going to basically count the amount of errors an ORC has made. So basically, given string with 7 letters, we want to count the amount of times that the letters do not match with the word Pusheen. This is similar to a mock CCC contest, a junior contest. For our second problem, we're going to count the average length of each word in a sentence. For our third problem, we're going to create an alternating letter case. So for example, if the first letter is lowercase, the next has to be uppercase. So the first letter is going to be lowercase, the next is going to be uppercase, and it's going to alternate like that, and only letters are affected by this pattern. So these are the common string methods. They're just ways of how to manipulate a string. So, of course, there are many more. You can read the full list here, or you can just Google, Java string methods, doc, or whatever. Of course, some are more common than others. There's toUpperCase and toLowerCase, which returns the string in all capital letters or lowercase letters. There's length, which returns an integer of how long the string is. There's toString, which basically takes a character and turns it into a string. There's equals, which is used to compare if two strings are the exact same. There's indexOf, which is the position of characters in a string. And there's trim, so it removes the spaces at the start and end of a string. This might seem ambiguous or a bit confusing, so we're going to go over a few examples of how to use each one. And I'm also missing one last method, charAt, which is really common, and you'll see us use it in the problems. CharAt basically finds where a specific character is located in a string. So for these first couple of examples, we're just going to use the same string because it's just more convenient. So let's start a string with a very basic one, just the first letters of the alphabet. A, B, C, D, E, F. If we want all of the characters in the string to be uppercase, we can just print str1 dot toUpperCase, like so. And it has these brackets. The brackets are normally used if there is a parameter, basically a restriction, I guess. But in this case, for these methods, at least these few methods, we don't need them. You can also make them toLowerCase, and this should print out A, B, C, D, E, F, and this one should be A, B, C, D, E, F, like so. And if we run it, we get what we expect. For length, again, it prints out an integer, or it basically takes the integer of a string, aka how long the string is. So if we wanted to find the length of a string, we just do the string name, like so, or the variable name, dot method, and then it will always end in these brackets, even if there isn't a parameter. And if we count the amount of letters, see, this is the first letters, second, third, fourth, fifth, and sixth. So this, if everything goes well, it should print out 6. Like so. For this next method, this is actually really common. It's charAt. So if we want to find, let's say, the first letter of a string, we just want this capital A. What we can do is we can just create a variable called first letter, and we can just take the string name dot charAt, and we want the first letter is actually where the index is equal to 0. So even though this is 6 letters long, when we consider the indices, A is actually stored where, I guess, the index is equal to 0. And so if we only want to print out the first letter, we can do something like this, and we should get a capital A. Like so. And if we have something toString, we need a character in order to turn a character into a string, we can just use what we have here. So this can be used if we want to treat a character like a string. If we want to manipulate it and use other methods, we can use this method. So what we can do is do system.out.println. All we need to do is character, capitalize C, toString, and then the character name, like so. So even if we printed out, there won't be any difference because a character looks like a string, but we can now manipulate, if we set this to a variable, we can manipulate it like it is a string. Now for dot equals, I believe I've used this before in a previous lesson, maybe, but we can just go over it. So we can create another string to compare it to. So we can just say, make string 1, this is a string, and this is a string. So dot equals is actually a boolean, so it'll print out true or false. If you want to see if string 1 equals string 2, we can just do string1 dot equals, and then within the parameters or within the brackets, we can just do example string 2. And since they are equal, the exact same, then we should see the computer print out true, like so. And if it wasn't true, say string 1 didn't have an exclamation mark, then it should return false. So even the smallest of details can show that two strings aren't equal. So for indexOf, it's essentially finding the placement of a character in a string. So if we want to find the first occurrence of I in the string, we can just do string1 dot indexOf, and then within the parameters it should be a character. And since the first letter or character is always starting with 0, that means the output should be 2. This only works for the first occurrence of the letter, it only outputs the first one. As you can see, it says 2. Now, if we want to find the index of the second I, we can just actually add another parameter with a comma. So if we add 3, as you can see here from my IDE, it says character, then from index. From index means it basically starts from this character onwards to find where the next character is. So if we print this out, it should give us a 5 like so. And this is useful if there are multiple characters and you only want to find multiple of the same characters and you only want to find a specific instant of it and regular one. So let's say, which one is unique? I want to find G, where G is. There's only one instance of G. Then we can just use this and we don't have to worry about what index to start from. So this doesn't have as many restrictions. And it's 15. And if you count this out, it should be 15. This should be the 15th character. For trim, it's actually really useful when you get user input. So if we want to get user input, we could just use a scanner like always. Just set it up, system.in. And we can, let's say we have a program that asks the user for their name. So we can just get their name like so, as we have with other user inputs. And I'll show you the difference of using trim and using without trim. So if I want to say your name is, a space and a name, and then an exclamation mark. So this, the first system.println, is without a trim. But if I use a trim like so if I just do name.trim, because it's string, and exclamation mark, if the user has a lot of spaces and you don't want those empty spaces at the beginning or the end of a string, then trim basically removes that. So you don't have to individually use a loop and test if the character is a space or not. Instead, you could just use trim for the beginning and end. So let's say name. We have spaces here. We also have spaces here. So as you can see in this first instance, there are spaces and it makes it look awkward. And the second one is just without spaces at the beginning or end. So this does not trim if there are spaces within the string itself. So it just removes at the beginning and at the end. So let's get on with our first problem. So since we're asking for user input, we need to add a scanner, and basically we also need to initialize a variable. So in order to do this, we can do this like as we've always done. So scanner system.in. In this case, we can just get their string by doing this like so. And since we want to compare the user input to what Pusheen is, we can just initialize another variable called Pusheen and have the string itself, so it's easier to compare. And we also want to count the amount of errors, so we want to include an integer variable like so. In order to find how many errors that the user input has from Pusheen, we can just use a for loop because we know the maximum length is whatever this is, which should be 7. So int I equals 0, I is less than Pusheen.length, and again this gives integer, and we just need to increase by 1 each time. Now if the string itself, or the user input, or the OCR, whatever, has a character at the same instance, so it starts from 0 and from 0 goes all the way to 6, and if that does not equal whatever the character is at Pusheen, then we know that there is a deviation, like so. And to increase one, we can just use errors plus plus like we have for the amount of iterations. And so this will repeat until we've reached the maximum, which is 7. And at the end, we can just print out errors. So if we run this and we input Pusheen, there should be 0 errors like so. Now if we run it again, let's say there is a 3 instead of an E because the OCR read it wrong, then there is 1 error. And this is just a way of how we used length in for loops, which is quite common, and charAt to determine if, let's say, the first letter of the string was P, and if the second letter of the string was also P, then it wouldn't count as errors, but let's say the first letter was S, then it would count as an error. And this continues again until the length has been reached. Important thing to notice or to think about is making sure that your iterations are within the length of the string. Sometimes you might get a string index out of bound, and if you get that, it's normally something wrong with the way you set up your for loop. And that's how you solve the first problem.
Alright, so in today's lesson we are going to solve a fairly difficult problem. The problem is that we are given a sentence, and then we have to find the average length of each word in the sentence. We are going to define a word as basically any amount of like letters or characters or whatever, combinations of that between spaces. So like a like that would be a sentence with 3 words in it. Basically, it's just whatever is separated by a space. We're not going to go any deeper than that. But even then, this is a fairly challenging question. So we are going to be seeing how string functions can be very useful to let us solve this. So I'm going to start by making a scanner since we need to be given a sentence. So I need to receive the sentence from the input first. And next I'm going to make a variable to accept this sentence from the user, so let's go with the string sentence. And I'm going to use next line because that way I can get a string result. I'm going to get an entire string input. I got the sentence now. Now let's think about how we can separate the words. So as I said before, we are counting a word as the characters and letters between 2 spaces. Alternatively, the very first word and the very last words. So what we would have to do is that if we go through every single character, once we identify a space, we can take the length of the word before it. And the length of the word before it would be where that space is minus however many characters the last space was. So to make it more clear, for example, we would have a sentence perhaps Alright, so to explain what I'm trying to say, let's say this is our sentence. Ignore the fact that it's not capitalized, that does not matter. We're programmers, we don't care about English grammar, only Java grammar. So if this were the string that we would be given, then each character is a certain location in the string. So this would be character at position 0 because Java likes to start counting at 0, so just get used to that. That would be 1, 2, 3, 4, 5, 6, 7. That would be the full sentence. And then to find the length of one word, we would have to identify it whenever we get to a space character. So we would go through every single character in the sentence. We reach a space, and then we could do 3 minus 0, and that would get us hey, which is the length of hey. So 3. And then for guys, we would do 7 minus 3. Well, we would get the end of the sentence minus third position to get 4. Now this is a simplification. You're going to see we are going to end up running into a few small problems when we get to the beginning and the end of the sentence, but as we are thinking the logic stage, this is what we are trying to do. And to find the average length of the word, what we could do is the average is the sum of all the words in the sentence, the length of all the words in the sentence divided by the total number of words. So we could have one variable storing this and one variable storing this, and that basically plans out how we are going to write the code. So going here, let's implement everything that I just said. First, we know that we need 2 variables, right? We need one variable for the 3 here and one variable for the 0 here to store the 0. So we need the current position and we need the previous position. So let me start by making previous position. So that's a character. That's what we will be dealing with strings. Character prev space. And I'm going to start by defining this as 0. So the first previous space, in quotations, would be the very first position. Next, we want to get the current character, and we want to go through every character in the sentence. So this can be best done with a loop. So I'm going to initialize a for loop here. A for loop, well, a while loop can also work, as long as you stay below the length of the sentence, it works. I prefer working with for loops, and the majority of the time, for loops just look cleaner, in my opinion, than while loop. But that is a style decision. So now I have I defined as the character in the current space. Next, we need a variable for the sum of every word length that we get. So I'm going to make int total length is equal to, set it at 0. We also need the total number of words. So I'm going to make int total words is equal to 0. So next, we know that we got the current character and we want to know if it's a space or not to continue. So I'm going to use an if statement. So if it is a space, then proceed. How do we check if the current character is a space? So first, we need to be able to get the character, because right now I is actually just index of the current character. So I is just a number from 0 up until the number right below the length of the sentence. To get the character who is at that number, we would have to use sentence.charAt. Here we are looking for the character in the string sentence at the position I. So using charAt, we can get charAt 0 would be H, charAt 2 would be Y, etc., etc. And we want to see if that is equal to a space, so I'm going to set it as equal to space. Now you might have remembered hearing that you cannot use this double equal sign with strings. That is true. Thus, this is not a string, this is a character. So this is the same thing as using the character variable, and for character you are allowed to use the double equal signs like this to say if this part is equal to this part. Just remember that you have to use single apostrophes. You cannot use double apostrophes. This will be a blow. This is a problem. This does not work. Characters can only be done with single apostrophes. That is a mistake I have run in many times, so I just want to make sure that nobody does that. Now we've reached a point in the code where if the code were running, we've got our character and we know it's a space. So we want to add the length of the word to the total length. So I'm going to do total length plus equal to the length of the word. The length of the word is going to be the position that we are at right now. As I said, I. We are going to subtract the position of the previous space. And then if we think about it, if I had this as my sentence and we had 0, 1, 2, 3, 4, 5, 6, 7. And this was the current space, this was the previous space. We would get 4 minus 1 is equal to 3 for the length of AA, which is 2, actually. So it should not equal to 3, which tells us that we want to do I minus previous space minus 1. But that runs into a different problem, which is if we have the very first one, we have 1 minus 0, that's equal to 0. You can't do 1 minus 0 minus 1 because that gives you 0, and clearly the length of this word is 1. So the problem we ran into there is because when we are looking at a word in the middle of the sentence, we are subtracting space from space. While when we are looking at the word at the very beginning of the sentence, we are subtracting space from the start of this word, not what we want. So our solution to that is going to be starting by pretending there is a space at the beginning of the first word. So I'm going to do that by putting previous space as starting with the number -1, and that should solve our problem. Our first one, anyways. Next, after total length, we are going to add 1 to the total amount of words that we get. So I'm going to do total words plus. And the last thing that we need to do is that we need to update previous space to wherever it is right now. Just position it I. And that should be it for our if statement little clause here. So that should go through everything perfectly, and we reach the end. Now we need to do calculations. So what we are going to do is that we are going to, as we said before, we are going to, let's say, make int answer is going to be the total length of the words divided by the total words. Now, one small problem here first that I see immediately is that when you're dividing, and you might not get an integer answer. So maybe we don't want to use int, and I'm going to change this to a double. However, as you can see from the warning here, this is going to still be an integer divided by an integer and still going to be an integer. Even though I have answer as a double, total length is an integer and total words is an integer. So what Java is going to do is that it's going to shorten it to an integer first anyways before giving it to answer. So you could do some more fancy things where you typecast this into a double, you change either total length or total words into a double. I found that the easiest way to do this, and the way I like to do this, is as long as you have one double in this entire equation, it will change the entire equation answer into a double. So I'm just going to very simply do 1.0 multiplied by everything, because now I'm going to include a double into the equation and my answer is going to be a double. Perfect. Now we might run this, and when you do, you are going to notice more than one. You're going to notice several problems. The first one is that if we ran through this with, say, the sentence and by the way, don't put periods. I forgot to specify, but this is while ignoring periods and other punctuation because that is going to make it unclear. So if our sentence input was just A space AA space AAA, then we are going to run through this. We are going to start 0 words. We're going to reach space 1, and at every space we gain a word. That means by the end of the code, we actually only have 2 words and not 3. So we are going to have to assume that this sentence is not empty and that you are going to start with 1 word. This way you can actually finish by dividing by the correct amount of total words. The next problem is that because the last time this stuff is triggered is at here, the last space, you are not going to be triggering it at the very end of the sentence. So you're actually not going to include this word, which is a problem. So we can do that by manually adding, instead of making the code more complicated somehow and adding this line. Likely if you have just 1 word as an exception, then you just add in that word manually. So I'm going to do total length plus or equal to, so we know that the last word is going to be the very last spot in a sentence. So that should be sentence length, right? The length of the sentence. And remember that we start from 0, which means our final character is actually at the entire length of the sentence minus 1, because this is position 0, this is position 1, this is position 2, etc. It's always 1 less than the actual length of the sentence. So I'm going to do sentence length minus 1, and then I also need to subtract it from the previous amount of spaces. So now our code should work. And moment of truth. Let me test. Hey guys. Oh, I'm dumb. I forgot to actually print out the answer. So you actually want to print out the answer. Now let's run it. Hey guys. 3.5, so that's 3 plus 4, 7 divided by 2, 3.5, perfect. If I run my 2.0, we have 1 plus 2 plus 3, 6 divided by 3 words, means 2 letters per words, perfect. So as you can see, this code is working. You can try a lot of them, and full disclosure, I had to debug this for a very long time. You can see all of these -1s and multiply by 1.0s and starting at -1 and starting the total amount of words at 1. Don't worry that if you've been thinking, I could never have thought of this myself, how did you manage to do that? I did not manage to do that in one try. I went through a fair amount of time of debugging that thing to be able to remember each of these things to do, and that's honestly a very, very big part of coding. You're going to get a lot of these, I'm not sure what's going wrong, why is my answer not working? What you do is that you keep trying. You keep trying different inputs, and I'll tell you, my debug strategy is print out everything. If you don't know what's going wrong, it's a lot harder to guess from here what each thing is. So what I would do is knowing the skills of how to debug stuff like this, very, very important. So the reason why I would print out this kind of stuff is that I can type in an example statement, and then I can see what happens every loop. On the first loop, we got I is equal to 1, previous space is -1, then I is equal to 5, previous space is 1. So if something goes wrong, this is where you are able to tell. This is how you can tell which loop got wrong, which number is incorrect, and then you look in your code and you figure out why it is. Is it because you started at 0 instead of 1, you started at 0 instead of -1, is it because you subtracted by 2, or you subtracted by 1, or you forgot to subtract 1 here? Coding is difficult in that aspect, and that's why nobody ever gets it perfect. So this is a question demonstrating, especially when you go further, string manipulation remains one of the things where it's easiest to go wrong somewhere or other, just because strings are weird, and also the fact that indices start at 0 is sometimes a blessing, sometimes a curse. And that's all it for me. I hope that you were able to follow with this code. I hope that this was able to help you a lot, especially that last little discussion on why it's easy to make mistakes, and why it's important to know how to debug and how not to despair.
So first we're doing this question called mocking SpongeBob. It's worth 3 points, and the goal of this is to be given any integer number of lines of input, and then you have to make this into a text like this, where it starts off lowercase and it alternates between lower and capital case, and then any character that is not a char, it's not a letter, you don't change it at all, you don't modify it. So we're gonna make this. You can already see I've set up the base code to take in the input and all that, and I've already taken a number. Now this step is very important. If we're gonna take a string after we take a integer, float, whatever, you have to write next line, or else you're gonna have problems in reading all that input. So make sure to put x.next line between when you're taking an input for an integer and then input for a string directly after that. Now we're gonna enter into a for loop. So for int I is equal to 0, I is less than n, I plus plus. The reason I'm doing this is we need to take some number of strings and number of times, and the easiest way to do that is with the for loop. And we're going to say string s is equal to x.next line, and then we have to go through this string individually and look at all the separate characters, and we can use another for loop for that. So for int, make sure you use a different variable. J is less than s dot length. This is how you get the length of any string. It's with that string method, and j++. So first, there are many ways to do the alternating between lower and uppercase. I like to use Boolean. So I'm going to make a Boolean up here in my code. I'm just going to say Boolean cap for capital is equal to false. It's going to be false first because we want the first letter to be lowercase as the question specifies. And then, now we want to make another string. So we're going to say string new string is equal to this, and we're going to add, this is an empty string right now, but we're going to add letters onto it that are the lower or uppercase or whatever it needs to be. This is just the easiest way to do the changings. So now we're going to say if character.isLetter s.charAt J is true. So what this does is it's saying, okay, we'll look at the character within the string S and look at position J. Is that character a letter? And if it is, then we can detect whether it is lower or uppercase, and we can make the changes. Or not detect, but we can make it into lower or uppercase. So now we're going to say if cap is false, so if it must be a lowercase, then we will say new string. Nope. The way you say if cap is false is if the exclamation mark is in front. Then you're going to say new string plus equals to s dot char at j, so add that letter. But then you have to say character dot toLowerCase. You'll see that function already comes up, that method comes up, and then that's how we add the lowercase version of whatever that letter is to new string. And then don't forget to change capital into false. And you're just going to do the same thing for if capital is true. So I'm just going to say else. This will be if capital is true, so then if it needs to be a capital letter at that spot, we're going to say new string plus equals to character. Look at that, character dot toUpperCase s dot char at j. And then we have to change cap back into true again, so that it, oh actually this is supposed to be true, right, and then this is supposed to be false. And the reason that we do that is because right after we've collected, like let's say a lowercase letter, then we know we need to collect a capital letter, so then it'll skip this one the next time and it'll go to this, and then we'll add the next one to be capital. And that's how we make it alternating, just like this. And then from there, we're just going to have another line of code here that tells us to just add it. So else, if the character is not a letter, you're just going to add it. So you're just going to say new string plus equals to s dot char at j. And then that'll just add whatever string it is. And then you can just go ahead and print it.
So as I was saying, you're just going to break out of this for loop, since this is the area in which we deal with every single letter of the string. You just leave that, and then you print out finally what the new string is. And then this will have the desired result of alternating between capital and lowercase. I'll just show you how to do that right now. So I've just copied the code from Debugging in the input section that they have to test it, and I'm just going to print that right here. And you can see that after I click enter once, we have, I don't even know how I like that, blah blah blah, we have all of the correct ones, we have even spacing included as well, and everything looks alternating, and now we can go ahead and check this. One thing with Debugging though is that they're not very strict on how you print it out, so you can see that I printed this like right next to what the input would be. They don't need you to have everything lined up and perfectly spaced, as long as you print it out just at the end after you've generated the string. So as you can see, we have done everything correctly, and yeah, that is how you write that code.